Okay, so let's say we have this problem. Okay, so we know how to take the derivative. That's not the problem. But let's use Desmos first to answer this first question. How are we going to, because a lot of times in math, we like to take two-dimensional objects, which would be this graph, and kind of say what it's doing on something called a sine line. Okay, so let's bring up our Desmos family. Graphing. And let's graph this. Y equals x raised to the third plus 2x x squared. Oops. Minus 4x minus 8. All right. So this is our initial problem. Okay, so as I go to the left, it goes to negative infinity. As it goes to the right, it goes to positive infinity. So let's find some values that are somewhat important for us. Okay, I can't find it. All right, so do you recognize that at -2 it's a bounce? Do you recognize right here it's a bounce? And this is a cross. I don't have any wiggles in there. I just have bounces and crosses. Okay? So let's talk about what this graph is doing. So -2 and +2. So -2, 0 created a bounce, and 2, 2 was just a crossing. Agree? All right, so let's use something called a sine line. We're going to call this a sine line. So there's things that I could put on there. I can put the -2 on there. I can also put the 2 on there. Okay, so if we go back and forth with our problem, we can see a few things. On Desmos at -2, let me see how I want to say this. I want to see if I can say it the right way. Let me get rid of this. Get rid of this. Get rid of this. No. Get rid of this. All right, so on our sine line, this region right here to the left of -2, if I were to find the tangent line anywhere along this line, would you feel comfortable to say that the slope of the tangent line anywhere along this region would be positive? Does that make sense? And if I find the slope of the line anywhere on this region between -2 and +2, this would have a negative slope. If I found anything from here, from this minimum value up, this would be a positive value. Okay? So 0.67, that's at 2/3. So 0.67, which 67, geez, come on, stir, which is the same thing as 2/3. Okay? So there's things that are taking place. So what I could do is if I'm talking about the slope over here is positive. The slope right at this region is 0. The slope in between here is negative, and then this becomes a positive slope here. And it stays positive as it keeps going. Okay? So I'm relating to what the slope would be. So it's either positive, negative, or 0. Yes, you can have an undefined slope if it's a vertical line. So that's kind of what's taking place. So let's try let's do this. Let's graph the derivative. Let's graph the derivative. Oh, that should be squared, sorry. Let's graph the derivative. Okay, so that's the derivative of the function. Okay, so let's see what happens when I graph the derivative with this on top of it. Y equals 3x squared plus 4x minus 4. All right, so notice what the derivative is doing. So the blue is the derivative. Okay, so we have -2, and then we have 0.667, which is 2/3. So at -2 and a 0.667, something took place on this problem. So here, and here, something took place. Okay? So if you look at those values, if you look at these values, the slope of the original was positive here. The slope between these two is negative, and the slope on the right is positive, okay, on the original. If I look back at my function, notice this region here. Is this blue region right here from -2 going to -infinity? Is that above the x-axis? And is the region from 0.667 above the x-axis? So that means the region between -2 and 0.667, or 2/3, is below the x-axis. Okay? Huh. Go back. So if I drew the f prime, I have -2 and I have 2/3. If we list above x-axis, that's going to take place. Okay? So above x-axis would be a positive value. So it's positive here, it's positive here, it's negative here. So it's not necessarily talking about what the slope is, it's just talking about where the f prime line is. What is the reference? What is the reference of our original graph by looking at it? By where does it go, above or below? Okay. It also talks about different turning points. So this had a turning point at 0. This had a turning point here. Now, let's go a little bit bigger function. Let's do see if I can multiply this out. That's x to the 4th minus 13x squared plus 36 times x plus 2. Minus 26x squared plus 72. So x to the 5th, done, plus 2x to the 4th, done. All right, so let me put a little bit bigger function up there. So I have y equals, x raised to the 5th plus 2x to the 4th minus 26x squared plus 36x plus 72. Oh, I made a mistake in my multiplication. 13x. X to the fifth minus 13x to the third plus 36x plus 2x to the fourth minus 26. Oh, 26x squared plus 72. Oh, biscuits and gravy. What did I do wrong? I goofed up. Fifth minus 13x to the third plus 36x plus 2x to the fourth minus 26x squared plus 72 x to the fifth what did I do wrong? Like, I don't know, Stirp. Can't see what you're writing down on your paper. Sorry. I think I found my mistake. Yes, there it is. There's my mistake. 2x to the fourth. I forgot one term. Minus 13x to the fourth. There we go. X plus 3, x minus 3, x plus 2. X to the fifth, 2x to the fourth minus 13. Oh, 13x to the third. I'm almost there. There we go. Okay. I haven't gone entirely crazy. All right. So notice we have a few things on this graph. So let's put our zeros in. So those are my zeros on that. Should be one more, I believe. Oh, x plus 2 happened twice. There we go. So this is a fifth degree polynomial. So if I were to look and I wanted to count up, make it fifth degree, it means I have to have 5 crossings of the x-axis and they're all rational roots. So I have 1 here. This counts as 2 because it's a cross. So 1, 2, 3, 4, 5. It's raised to the fifth power. So there's things taking place. So at this region here, this region right here, it's positive. This region here, it's negative. This region here, somewhere taking place up here, changes from positive to negative. So let's see if we can figure out all of our points that are important for us for our sign line. So I'm going to get rid of, I'm just looking for the max values. So it looks like negative 2.694. It's a max. At negative 2, we have a local min. And if I take this up way too high, hopefully I can find that. And then at 0.519, I have a max. And let's lower down. And at 2.575, I have a min. Okay? So that basically, by using Desmos, let's see if we can do something with this function. So if we graph this function, basically some things that we will know about is at negative 2.694, we're going to call this a min. At negative 2, or shoot, we're going to call this a max. I'm sorry. Jeez. All right. So if we have a max, that means that the slope went from positive to negative in between those. So at that max, at this min, it goes min to max, it goes from negative to positive, from max to min. So min to max is positive, from max to min is negative. And then over here, that would have remained it rest on positive. So these values are talking about the slope sign. Okay, so if without having Desmos there, you'd basically know that this graph does this, does this, does this, does this, does this. So we're just talking about what the slopes are doing using a one-dimensional picture of a two-dimensional picture itself. Okay, x to the fifth would be the second dimension because it's to the fifth power. Okay, so, and we did have bounces and all those kind of things. Okay, so a few other things took place. Let's take a look at that. Okay, so what we're trying to decipher is once we get to this point, can we just by looking at it, can we tell anything different? Now, if I take 5x to the fourth plus 8x to the third minus 52x plus 36, being that's the derivative. If I plot a derivative on that, no, my derivative right. Jeez. 5x to the fourth, 8x minus 39x squared minus 52x. Oh, undo. Plus 36. This is a train wreck looking thing. All right. Somebody's talking slang out there. You guys might take care of my business. They're dropping F-bombs out there. Making me feel offended. All right. So you have the purple, then the green. Okay, the green was the original. So we have a positive slope here, and then this turns into a negative slope. I don't want to do this purple. So this value here is the same as this, the max right here. I realize I have a dot. Get rid of that dot. I don't want that dot. So I'm getting dumb. I told you this was a train wreck. All right, so notice where this max is right here at 2.964. Okay? And then if I come down to the x-axis, this value here becomes the negative 2.964. So with that known now, if I have so this is my y graph, and if I did my y prime graph, this is going to look where it's below the x-axis. Okay, so I have negative 2.694 to negative 2 to 5.519 to 2.575. Okay, remember we're just saying where it's above or below. We're not looking at the direction of the slope. So we are above here, below in between, above here, below here, and above here. Okay? So if I were to just have given you these two pieces of information and you did not have anything else, you could decipher somewhat what this problem would look like as far as directions go. And I know that that was a goofier way of looking at it. So let me give you just a couple problems. So try these. And I want you to make the original slope line showing positive or negative slope. And then I want you to do the f prime or the y prime showing where above or below. All right, so let's just kind of keep it simple. Try this one. Try this one. And try this one. So try these three. See if you can figure these out. You just do it on a separate sheet of paper. See if you can get an attempt of those three, showing just the sign lines, where the original sign line is showing where the slope is positive or negative, showing where it changes from positive to negative to on the y prime where it shows it's either above or below the x-axis. Deal?